Today we're going to begin Unit 8, which is quadratic functions. Student handout 1 is going to be over the introduction to quadratic functions. I want to point out the U shape in the word quadratic because that shape is going to be important when we're graphing quadratic functions. Okay, so to begin, a function of a degree of 2. Okay, so what does that mean, degree of 2? That means the equation has to have an x squared. The standard form of a quadratic function is ax squared plus bx plus c, where a, b, and c are the real numbers and a cannot be 0. Okay, let's talk about why a can't be 0. If I have 0x squared, well, 0 times anything is going to turn to 0, which means this would disappear. It would no longer have a degree of 2. It would actually become a linear function. So we cannot have an a value of 0, or it will no longer be a quadratic function. Okay? The graph of a quadratic function is called a parabola. Okay, that's that U shape I was talking about before. A parabola appears to look like a U, except your U can either open up or your U may open downward. Okay, so in the next section, it's going to be important to be able to label your A, B's, and C's, which we already did in Unit 7. So this should be pretty easy. So the beginning is ax squared. So we know that a is 2. The middle term is a positive 4. So we know that b is 4. And then the third term is 8. So we know that the c value, the constant, is 8. Okay, let's do a few more of those. First term, a equals 5. In the bx term, notice there's a minus there. So the b is a negative 8. And then your constant c equals 10. I'm going through this quickly because you should remember this from the last unit. So the first term is x squared, and we know that that is 1x squared. We just don't write the 1. So our a value is 1. Our b value is 2, and then our constant, the c value, is negative 3. Again, there is no leading coefficient, so it's understood that the a value is 1. All right, in our middle term, we have a minus 1, so b is a negative 1, and then our constant, c, is a positive 1. Okay, that should be pretty simple. Now let's talk about what the graphs are going to look like in a quadratic function. Okay, so we already said it's like a U, because if you look at the U in the word quadratic, that tells you, it's a little reminder to help you that the shape of the graph is going to be a U. So I can put this U anywhere on the coordinate plane. Here I have a parabola opening up, or I can put a parabola opening downward. Both of these are good examples of a quadratic function. So what would be non-examples? We want non-examples. Okay. Well, let's put this up here. If your U shape, it's not very pretty, but if your U shape is going sideways, it is not a quadratic function. Doesn't matter if it's going left or if it's going right, it is not a quadratic function. Okay, so what are some things we just learned? Okay, looking at that information that we just talked about. Okay, first of all, for a quadratic function in the equation, what do we say the equation had to have? The equation must have an x squared term. Must. Okay, your equation must have an x squared term. Okay, what about the graph? What did we just learn about the graph? Okay, the graph makes a U shape. Okay, the graph must make a U shape. That's called a parabola. Okay, but what can it not have? No sideways U's. Okay, your U cannot be sideways. Okay, so we're going to look at this quadratic function over here that's graphed. You see the parabola, and it says the graph to the right has some important points marked. What do you notice about them? Okay, so let's start pointing some things out. Okay, first of all, let's look right here. We learned well before Christmas when it touches the y-axis, it is called a y-intercept. So we have one y-intercept. Okay, one y-intercept. Okay, all right, next we can see that it touches the x-axis twice. So it has two x-intercepts. Okay, then you can probably notice that there's a point at the very bottom. Well, that wasn't a very good color to pick because it looks too much like the other pink, so I'll use black. This point at the very bottom is the lowest point on the graph. It's the lowest point. We actually call that a minimum. That makes sense. To be the lowest is to be the minimum. All right, and next, it's not on mine very well. It didn't print, so I'm going to have to draw it in. There is an imaginary line, imaginary vertical line that goes through the middle of the parabola. So a dotted line down the middle. All right, that dotted line is actually called an axis of symmetry. We'll talk more about that on the back side. Okay, an axis of symmetry. Okay, so if you will go ahead and flip over to the back, you'll see we have this diagram in the middle where we have the quadratic function graph. That's a nice parabola. And they have the x-intercepts marked, the y-intercept, the vertex, and the imaginary axis of symmetry. So we're going to talk about a few of these things. First of all, let's talk about the a value that's at the very beginning of the equation. If the a value is positive, that will automatically tell you that your parabola will open up. It's going to look something like this. Sometimes it's narrow, sometimes it's wider, but it's always going to be a parabola that opens up. Okay? All right, then if the A is negative, well, that means that it's going to open down. And it's going to look something like this right here. So if you look at this graph right here, this example, would you guess that the A value is positive or the A value is negative? the A value is positive because the arrows are going up. So it's opening up, it has to be positive. Okay, next we're going to talk about the vertex, and you'll see in your diagram they've labeled the vertex green. Okay, if the vertex is the highest point, we call that a maximum. Okay, if it's at the very top, it's a maximum. Or if it's the lowest point, we call it the minimum. That makes sense. To be up at the top is max and be at the bottom is minimum. So let's go find this point right here. Here's the origin, and we move one right and down 1, 2, 3, 4. So the vertex is actually the coordinate 1, -4. So that's the vertex. Okay? That point on the parabola, it would be the minimum point, is 1, -4. Okay? So that one is actually the minimum. And the number that made it go down was the y value. So we would say the minimum is y equals -4. Okay, next let's talk about the x and y intercepts. Okay, you'll notice here's the x-axis. It's going to cross 2 times. So where it touches the x-axis, we call the x-intercepts. So the x-intercept crosses the x-axis. And they're telling you to look up here in red. So let's get these two coordinates. Okay, there's 2 of them where they cross. So starting at the origin, 1, 2, 3 to the right, and then 0 up and down because it's on the x-axis. This one is moving left to -1. So there are 2 x-intercepts, -1, 0, and 3, 0. Okay, next let's look at the y-intercept. If it's a y-intercept, it's going to cross the y-axis. Here it is in purple. Okay, so here's the origin, left and right none, down 1, 2, 3. So this one goes down to -3. So the coordinate is 0, -3 for the y-intercept. Okay, now let's talk equations. We haven't talked a ton about equations. We did see some on the beginning on the front page, and we talked about how it was ax squared, bx, and c. That is actually called standard form. Just by looking at this equation, because I see x squared, I know it's a quadratic function that will look like a parabola. Another thing I want to point out is, remember, f of x can be just a y. You could rewrite this as y equals x squared minus 2x minus 3. Same thing. Okay, this, however, is a different form. It's called vertex form. Your a value is actually in front of the parentheses, and they don't have anything there, so we know it's a 1. But vertex, let's go look at the vertex. Vertex is 1, -4. Well, let's see the equation. 1, -4. There it is. So, this first equation is ax squared plus bx plus c. That's what we saw on the front page. But this vertex form, and they have it written as y, which is fine. It can be y or f of x. You have your a in the front, and then it's x minus h squared plus k, and your h and k represent that vertex. Okay, all right, next, zeros. The zeros. That's a new vocabulary word for us. So zeros are also known as x-intercepts. They are known as roots. They are known as solutions. So anytime they say the word zeros, x-intercepts, solutions, roots, you want to know where does the graph touch the x-axis. Okay, you can have 0 x-intercepts, it never touches, 1 x-intercept, or it could possibly touch twice. In this example, the parabola touches twice. It touches at -1, 0. It touches at 3, 0. So you would say the zeros are x equals -1 and x equals 3. All right, then the last characteristic we're going to talk about is the axis of symmetry. So when you were young in middle school, they taught you about a line of symmetry. That is a line that divides an object right down the middle. It's like a mirror image on the left side and the right side, or the top and the bottom. So now that we're on an x and y axis, we call this an axis of symmetry. So this axis of symmetry, it's imaginary, and it divides the parabola exactly in half, always through that vertex. So it's a vertical line through the vertex, because the vertex is in the middle. It splits the parabola in half down the middle. Always an x equals equation. So the axis of symmetry will always intersect the x-axis. Always, because it's a vertical line. So you can see this orange line only touches the x-axis. It's never going to intersect the y-axis. So in this example, the equation would be x equals, well, where does it touch the x-axis? At 1, which will always be the x value of the vertex. The imaginary axis of symmetry will always be x equals whatever the value of the vertex x value is. Okay, good luck.